Hello, and welcome to Waka Waka Breaking It Down. This is the video that's going to go over the practice test or the practice assessment for Unit 3 Rational Functions. So let's get to it. Hopefully, like always, you try these on your own and then you kind of listen to me and maybe work a problem and then come back and listen or work a problem, whatever you need. But you don't want to just sit there and listen without trying to do it yourself. So try to do this on your own as much as you can, but don't waste time either. If you're stuck, then you're stuck. Then jump on the video and then let's see if I can break it down for you. Okay, so practice assessment. So this would be a good review and getting you ready for the test. It doesn't have everything the test has, but it's going to be very, very similar. And of course, these word problems are always going to be a little different on the test than they are on the practice, but it should give you the same idea of like the idea of constructing an equation from a set of words or sentences like this. So let's get in it. This is the Booster Club is going to sell lottery tickets, and they're going to give out $10,000 as a prize to the winner. But it's possible that more than one person has the winning numbers. Kind of like you see that in lotteries in different states in the U.S. and stuff. But okay, so if they do have more than one winner, they're going to split it evenly among them. So we're trying to say like, well, let's say that we have X winners. Like we don't know how many, but let's say if it was two winners, then each person would get $5,000. 10,000 divided by two. If it was five winners, then 10,000 divided by five. Sorry, that would be $2,000 each, right? And then et cetera, right? So we say in general, if you had X winners, you'd be taking your $10,000 and dividing it equally amongst those 10,000. So that's where this little equation comes from, right? You just divide by how many people won, and that will tell you how much money each person gets. So that's writing an expression, right? When it says expression, that means you don't have an equal sign or anything. It's not really equal to anything. We could write a function. We could say, oh, this is f of x or something like that, and it wouldn't be wrong. We have no problem with that. But it just said write an expression, so that's all we did. So now it goes one step further and says, well, let's say that in the beginning we thought there was X winners, but then all of a sudden this extra person came along and said, hey, I won too. So we thought we had the money divvied up, right? This would be the amount that each person would got. But then we had an extra person come along. So however many people we had before that won, we're going to have to add one more to that. And then we're dividing again, we have to split up the $10,000 to all those people who we thought won before, plus the extra person. So this is our new expression on the previous winners, plus one more person. Okay. Now that's, on your own, you have to be able to think that through. And some people have a little trouble thinking that through. So really identify what did you call X, right? Those were the initial winners, and really identify that. So then when you move forward, it might make more sense in what you're doing, right? One more winner from the previous, right? It says another winner. So we got to write the expression using the X. We can't define X for one thing and then later on define X for something else. Like we can't make this X and just say, oh, no, that's the new X. We can't say that because we already defined the X. We can't do that anymore. So this then has to become X plus 1 now because that's already been defined, right? You can't change it. Hopefully that makes sense as far as moving forward and having to write these things, right? I know it's very tempting to just say, well, let's just divide by X the number of people. Doesn't matter. Well, you already defined it as the initial, right? So you got to be careful. Okay, moving on. So a new winner came forward, so everybody got, it says like after this happened, everybody got 500 less than they would have without the extra person. So here they got some amount of money. And then over here, when they got that extra person came forward, everybody had to like sacrifice $500 of what they thought they were going to get. So like I thought, oh, I'm going to get $2,500, initially. But then another person came along and I had to give them $500 of my money because and now my money went from 2,500 down to 2,000 for an example. I don't know, like we're going to calculate what the answer is down here. I don't know how much that is, but something like that, right? Where I ended up with 500 less. So what does that look like with the original stuff? Well, I used to get this much money, but then when the extra person came forward, I got this much money. So, and that difference is $500. So this is probably the way I think about it, where I'm like, this is how much money I started with, how much money I thought I was going to win. And then when the extra person came along, this was the amount of money that I actually got. So the difference between those, right? I'm subtracting those is $500. So hopefully that makes sense in your brain. Over here is a different way of writing it. Some people said, well, take the original, subtract your 500, and then you end up with what you actually got, right? It's the same thing. You know, I can add this to this side and then subtract this over to this side, and you'll get the same thing that we had over here. So now let's actually solve. We want to solve for x, the initial winners. Remember, we defined the initial winners as x. So we're solving for x. All right, so it looks like a lot here, but it's really just broken down for you so you can see. So take your original equation however you want. We're gonna have to, no matter which equation you use, I'm gonna move everything to one side, or at the very least, you're gonna have to get common denominator. So we definitely need common denominator. That's the main goal of solving, right? Okay, so I have to take the one on the left, or this 10,000 over x, the initial, and I have to multiply by x plus 1, x plus 1. The 500, I need to multiply that by both. I have to multiply by the x, and I also have to multiply by the x plus 1 to make that a common denominator, right? We're looking for x times x plus 1 on the bottom. Back in the beginning, that's what I had on the bottom, so that's what I want to make common. And then the last piece, you'll notice that from here, I just subtracted it over to the other side, right, to get this. So there's subtraction here. And so that already had the x plus 1. I just have to multiply by x over x to make it a common denominator. All right, so it says right here, you need a common denominator. Are all three of these the same? If so, you've done your job. All right, now once I have a common denominator, I have to just look at the tops. I don't need to worry about the bottoms anymore because they're all equal on the bottom. So I just have to make the tops equal to each other, or make it work out to equal 0. So I just kind of ignore the bottoms, take the tops, right? I'm just kind of taking all these tops and moving them down, right? Moving it down, moving it down, moving it down. And then it's a matter of simplifying. I got x's over here, I got x's over here, I got x's over here. I need to put all this together. And maybe that's kind of what you're looking for. Like, I got stuff all over the place. I need to kind of try and put this stuff together. So don't forget to distribute these. When you do that, don't forget these negatives go with it. These negatives get distributed into these. So this ends up being 10,000x, and then you get 10,000 here and here. This negative 500, and I'm going to take the x with it. So the negative 500x, all of that is going to get distributed into there, right? And that's going to give me negative 500x squared. Then the negative 500x also needs to go into the 1. So that's going to give me negative 500x. And then the last piece here is just going to stay the same. And then I have to put all my x squares together if I have any, but I just have the x squared. And then I have to put all my x's together. All these x's have to go together. So you add those together and you get this. You can see that 10,000x and minus 10,000x cancel. So you're left with the negative 500x. And then the 10,000 goes here. That just drops down. And then everything's kind of simplified, right? Equals 0. Now I'm noticing that if I want to make this a little easier on myself, I can divide everything by negative 500, right? And kind of divide that off to simplify. So this divided by negative 500 is just x squared. This divided by negative 500 is just x. And then 10,000 divided by negative 500 is negative 20. So I'm just dividing everything by the same number to kind of simplify it down a little bit. The reason I can do that is because if I take 0 divided by the negative 500, right? If I do that, it's still just going to be 0. 0 divided by any number is still just going to be 0. So it says it right here. You're dividing everything by negative 500. All right, now I got a nice, easy quadratic I can solve. Factor it first, and then you look for the numbers, you look for the x values that are going to give you 0, right? What's going to make this equal 0? So -5 will, and also 4 will. Now we got to put this into context, and you always want to do that. I want to look back at my original equation. Is any of these numbers going to make that denominator 0? That's one thing I want to check. And the other thing I want to check is, do these numbers make sense in the context? What are we doing again? Oh yeah, we're talking about the number of winners. Can I have a negative number of winners? No, that doesn't make any sense, right? So we're going to eliminate this -5 and say, really, just 4 winners is the only solution that makes any sense, right? That's going to make sense. I can have 4 winners, okay, right? And if I wanted to, I could figure out how much money we actually got, right? 10,000 divided by 4, that's 2,500. Oh, I was right when I first guessed. I didn't even know that, I just guessed. So 10,000 divided by 4 would be your 2,500 each. At least that's what you thought in the beginning, and then the extra person came along, and we all got 2,000 instead of 2,500, right? All right. This takes logic, you know. So those of you who try to memorize steps, these logic questions where you have to kind of make things match what's going on in the situation, those are going to be hard for you. You really got to break it down because it's not just memorization, right? You have to apply kind of the ideas of dividing by some unknown value. You have to apply that to whatever's given to you, no matter what it is. So that takes thinking, logic, and problem solving skills, right? Critical thinking and problem solving. So here we go. Reasoning, yeah? A lot of reasoning in this. This is all reasoning. You can see this is reasoning on the test, right? And this one's reasoning on the test as well. All right, one more word problem here. So this one is, they're going to give us an equation on this one and just say, hey, you know, this C is the cost of how much it costs to remove pollutants from some manufacturing process, right? So when you look at this, it's kind of, to me, it's like, I have this P here. What's P represent? I kind of want to know this. Oh, so P is the percent of pollutants in like a waste byproduct. So it's a percent. It's the percent of pollution. So when I'm looking at this, I'm like, okay, I got 1,500 times that percent. So the higher the percent, the more money it costs, is what I'm kind of thinking. And then when I look at the bottom, I have 100 minus P. And P is a percentage. So maybe the 100 represents like 100% of something. Maybe that's what's going on. So 100 minus some percentage, something like that, right? I don't really have to know exactly what this means, but I do need to really understand what the P means because that's part of my function. That's part of my equation. All right, so they say C of 5. Well, this just means P is 5, right? You can match those up, match up that notation. So if P is 5, you plug that into your equation. You can see here that we did that. Just plug it in, grab your calculator or your baby calculator, and come up with $78.95. So we put that in context. It will cost $78.95 to remove 5% of the pollutants, right? We're removing pollutants from this process, some waste byproduct, right? So it costs us money to remove these pollutants. All right, so you want to put it in context. Not only are you telling me what the 78.95 is, but you're telling me what this 5 is as well. Okay, so $78.95 and 5%. Same thing here, but now this is a little backwards because now they're giving us the dollar amount. They're giving us the cost here, right? They're saying this equals that. So I have to take this whole equation equal to that because that's what they said this was. So that's what we did here. You can see we took that whole equation equal to the 28,500. All right, now I need to solve that. So the easiest way I think is to just multiply both sides by this 100 minus P. So that's what I did here, right? You multiply that on both sides of the equation. On this side of the equation it goes away, but then it shows up on the other side of the equation because you multiplied it over there, right? So that's what you're seeing here. And then on the right-hand side, we just have the 1,500 P left over. 1500p. Okay, so I got to keep going. So let's distribute this in. So right here, I'm going to distribute that in. That's what you're seeing here. And then I still have the 1500p left over. Make sure you're organized. Like a lot of people miss these types of problems because they're doing little pieces and they're not very organized. And then they lose track of where they're at and what it's equal to and all these things. You'll notice I write the whole thing out every single time. And every step I take, I'm still going to write the whole thing out again. Even if it's the same as what it was before and nothing changed, I'm still going to write it out again. Here, I'm subtracting 1500p over to the other side of the equation. Or I'm sorry, I'm going the other way. So I'm going to move this over to the right-hand side, and I'm going to move this over to the right-hand side as well. Oh, I'm sorry. Sorry, back up. I want to get my p's together. That's what I'm doing. So I'm going to move this over to this side of the equation so I can get my p's together. Get the pieces that have p's in them. Okay, so now I have my p's on one side of the equation. And those add together then. And then this is an easy solve by dividing by 30,000. So you divide by 30,000, divide by 30,000, and you end up with 95. Okay, so what does that mean? Well, for 95% of the pollutants, that's what P is, it'll cost me 28,500, which is what they gave me in the prompt, right? Sweet. Now that's a little work, right? It looks like a little simple thing, but you gotta solve that by hand here. I mean, you can have your baby calculator, but you don't really get anything else. You don't get your big calculator. All right, so what does a vertical asymptote mean in the context of this problem? We have to find that, and then we have to explain it. So when I look at this equation, the vertical asymptote is going to come where the denominator is 0. All right, so denominator 0, when's that going to happen? Well, that's going to happen where P is 100, right? Because 100 minus 100 will give me 0 on the bottom. So if P is 100, that makes the denominator 0. That means the whole equation is undefined, and that's where I'm going to get a vertical asymptote. Now, what does that mean in context? If I have P of 100, well, remember, P is the percent of the pollutants. So this, if I have 100, that means I have 100% of the waste byproduct is pollutant, like all of it, the whole thing, 100% of it is just pollutant, pure pollutant, nothing else in there. So that's like, if you think about it, it's kind of maxed out, right? It's like 100% of it is pollutant. I can't go more than that. So I'm not really going to be able to go like more than 120%. So maybe at 100, right? Whoops, let me graph this out differently. Let me find some space here. Here we go. I got a little space right here. So if I were to graph this out and I go from a pollutant percentage of 0 up to 100, I'm going to have a vertical asymptote at 100. And this is going to probably shoot off, like my cost is going to get higher and higher and higher as I get more and more pollutants in it, right? The higher percentage pollutants, it's going to shoot off, right? So it's going to go up that asymptote. And that should make sense to us because I can't have more than 100% pollutants. Once I get to 100%, it's just going to shoot off. And it's kind of going to get exponentially bigger and bigger cost as I go, right? So we said that here. So as it approaches 100, the cost gets larger and larger all the way to infinity when you reach 100, right? So as you reach 100. All right, I'm going to move on. I know the word problems are the toughest. They really are. You really have to kind of think your way through those. There are little things you can focus in on, like defining variables is nice. Really making sure you answer what they're asking for, right? What are they asking for? Here it says initial winners, not the winners at the end or anything like that. And then really matching up notation, like matching up a P to a number here, matching those up so you know that this 5 actually represents P. Matching up this, right? So matching up things. There are little things you can do, but you got to really look out for them. And then in the end, you really do need to logically figure it out on your own. How do I make something fit the situation? And when I write it, does it make sense, right? You can ask yourself, does that really make sense? Does that make sense? That's a good thing to do. All right, let's move on. Number 3. Now this is understanding, so a little more basic, just putting things together. Again, when you put these things together, all this A through D, you're always just trying to find common denominator. So on this problem, you can see the common denominator is 2x plus 2, which is here. This one didn't have 2x plus 2, so I had to multiply by 2 over 2 to make it a common denominator. Once you have your common denominator, you can just add the tops together and put those over the common denominator. And then, of course, you're trying to simplify. This becomes 6. 6 divided by 2 is 3. So you'll see I have 3 there. The x plus 1 just stays, right? All right, next one, same process. I'm looking for common denominator. The one on the left, I have to multiply by x plus 3 and x plus 3 in order to get that common denominator over there. The one on the right, I'm going to need to multiply that by x over x. So you can see that's what I did here. And so that makes the bottoms common, right? We have common denominator. All that stuff goes with the top though, right? You can't ignore that. And here's what I'm noticing here is I have this subtraction. So I got to make sure I deal with that properly. A lot of people make mistakes dealing with the negative. All right, so this has all been, we found our common denominator. So now I have to take the tops and combine those under one common denominator, which, you can do that because these are the same. And then once I get that, you can see that all this stuff over here is now over here. Once I have all that, it's just a matter of simplifying. So I'm going to FOIL this out, right? I'm going to distribute that out, which you'll see here. And then I also have this minus x squared, which you'll see here. Okay? And then I can put things together. X squared minus x squared goes away. And just simplify whatever you can. Try to look for stuff that you can factor out or anything like that. There's nothing else I can do there, so then I just leave it. Okay, on C, there's one extra step. This one isn't really factored out for me yet. So I need to factor that out. And by the way, hopefully you're trying these kind of on your own first and then coming to the video. It's great to use the video. I want you to use the video, but maybe give it a look on your own first. See if you can do it without the video. And then if you can't, then come to the video. Or if you just want to check your answers and get some reinforcement, come to the video. All right, so let's factor this out. What you see we did here, it's just x minus 2x plus 1 will give us this. When I have that, then I'm checking it against the one on the right to see if those are common denominators or not, which they're not. So I need to make the right one. I need to multiply by x plus 1. And you can see that. That's what I did there. Okay, so now I have a common denominator. I can put the tops together under one common denominator now. Right? X plus, and then this gets distributed. So x plus 2x gives me 3x. And then we have plus 2, right? 2 times 1 is 2, which is where that comes from, right? There's nothing else I can do here. There's nothing else I can factor. There's nothing I can cancel. So I'm done. And then the last one works the same way. I need to multiply this by x plus 3 over x plus 3. Once I get my common denominator, I put the tops together. Don't forget to take this negative with this. This is where people really mess it up, right here. You're going to notice that this negative distributes into this. So it's not negative x minus 4. It's negative x plus 4, because this negative has to distribute to the x, but it also distributes to the negative 4. Kind of like if they were in parentheses, right? Then you would think of this as a negative 1 and distribute that in. Okay, don't forget the negative distributes into there. All right, so that's what we end up with on top. X's go together, right? And then numbers go together, and we're done. There's nothing else I can do there. Sometimes it says, warning, warning, right? Sometimes that simplified version, you can factor it more and you can simplify more. So just watch out for it. You got to look for it. Okay, more reasoning. Okay, this is all the graphing stuff, right? All those things that you're supposed to do for graphing. So first thing we want to do when we're trying to analyze the graphs is to factor it out. Like take out as much as you can. So I factor the tops, factor the bottom, and I just have this version on the side. The next thing I'm going to do is maybe look for the whole. That's probably the first thing I like to do. And then I like to write down what my simplified version is. This didn't have it, but this is what it would be simplified, right? After you cancel the x plus 1s. But I got to go over to where my whole is, and I have to write that down. Oh, there's a whole at x equals -1, right? That's going to be part of what makes this piece 0. Okay, but that's just the x value. I still have to find the y value that goes along with that. So I have to go over to my original equation, or sorry, my simplified equation, and put in -1. That's going to give me -4 on top, -1 on bottom. So that gives me a +4 overall. So that's where my whole is at, and that came from what canceled, right? So that matches that, right? Okay, next up, I can look at this and say, where is the bottom 0? Wherever the bottom is 0, you're going to get a vertical asymptote. So this vertical asymptote comes from that being 0. All right? Now, it's not just a number, it's an equation. If it's vertical, it's going to be x equals something, right? X equals some number. So make sure you write it as x equals 0. And that comes from the bottom. Horizontal asymptote. I always look just at the original equation. We're looking at these degrees. If the top and the bottom are the same degree, then I'm going to look at these leading coefficients, which in this case is 1/1. So that gives me a horizontal asymptote at y equals 1. Again, this is a horizontal line, so we want to make it an equation, not a point, right? If the bottom was a higher degree, then this would have been 0. If the top was a higher degree, then we would save that for pre-calculus. Oops, I got rid of that. All right, x-intercepts, y-intercepts are something we find sometimes. This particular one doesn't have it on there. If you did want an x-intercept, right, so an x-intercept, you would make the y value 0. So that would be, in this case, looking at where the top is 0, which would be at 3. If I'm looking for a y-intercept, that is where the x value is 0. Oops. And in this case, that's where I put 0 in for x. And in this case, I wouldn't have one because I'd be dividing by 0. So I don't really want that, right? So I'm not going to have a y-intercept. That's going to be gone, right? No y-intercept. Okay, but I would have an x-intercept. Okay, domain and range. So the domain is all the x values. We've done domain in Unit 1. We did it in Unit 2, so it shouldn't be anything new. You just have to think about this graph, though, right? When I'm graphing this thing out, the vertical asymptote is right at 0. The horizontal asymptote is at 1. And then I have this hole at -1, +4, like over here somewhere. So when I'm looking at x values, I'm noticing that 0 is not going to be included from my vertical asymptote. And the hole also has a value at -1 that is not included. So these two values are going to determine my domain. Okay, so 0 and -1. That's where these numbers come from. X is not allowed to be those. Same thing for the range. Same thing for the range. The range values come from the horizontal asymptote and then the y value of the hole. So here's where the hole is not defined, and here is where my y value is not defined. So that's why 1 and 4 are not part of my range, okay? So you have to kind of use this previous information. It comes from the asymptotes and the hole, right? The asymptotes and the hole, all the information will give you your domain and your range. Okie dokie. Now the next piece says, how do we know it's a function? And all we're looking for is the definition of a function. We've been doing this since Unit 1, and we want you to, like, people keep missing it, so we want you to, like, get it, right? We're going to keep giving it to you until we feel like everybody knows what a function is. So the whole idea is that for any particular x value I put into my equation, or that I graph, or that I grab, or that I take as an input value, right? So any x value I have, there's going to only be one y value that you get out of it for the output. I'm not going to have two different y values for any particular x value. There's only going to be one y value for every x value. And that's what we're looking for you to say. So for every x input, there's only one output of y. You don't get two different y values. Okay? All right, we're getting down there. There's still a lot to go here, but number 5 is the same type of problem, right? So you're doing the exact same thing. Just look for, you can see the pieces match up. This is what makes the bottom 0. This cancellation is what's going to give you your whole. The horizontal asymptote is coming from the leading coefficients, 1 over 5. And then our x-intercepts, that's what's going to make the top 0. That's -3. But remember, I'm not using the whole, right? The whole is not part of that. And then if I want a y-intercept, I have to put 0 in for x. 0, 0. Well, we don't use this. And 0, and then you find out what that equals, and that will give you your y-intercept. So that's just a repeat of the previous problem, okay? So ask me questions in class if you have more. All right, simplifying, and then we have solving. Multiplication, you don't have to do much as far as like common denominator or anything like that. You don't need to do any of that. All you do is just directly solve across the top, or sorry, I should say multiply across the top, multiply across the bottom, okay? So here's what you get on top, right? Multiply those out, multiply those out. Don't forget to distribute stuff, right? And actually, I'm trying to factor stuff, sorry. So I'm taking this 3x plus or minus 6 and factoring out a 3. And the reason I want to factor everything is because I want to try and cancel stuff, right? One of these x's will cancel one of these x's, x minus 2 x and x minus 2 cancel, and you just can see what you have left over, right? So factor it all out and cancel. This is division. The first step is to multiply by the reciprocal. So we have to flip this one over, flip it upside down, right? And then multiply instead of divide. I still have to factor, over here, factor. So I need to factor those. Once I factor them, then I can start canceling. Cancel, 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 and I'm left with x plus 1 over x. Okay, now I've got, oh, this is multiplication again. So multiplication, same thing. This is already factored for me. Cancel, 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 cancel. I just have x plus 3 over x left over. That was an easy one. Division, again, multiply by the reciprocal. Factor it out, factor it out, factor into that. Once everything's factored, you can cancel, cancel. Looks like that's all that cancels. So the rest of it is still sitting there. Okay? And solving. When you do solving, this is where you want common denominator, right? So you can see we do not have a common denominator. So I make a common denominator and then I solve. Once I get that common denominator, I can just look at the tops and make those equal. Now there is a different way to do this one. If you wanted, you could cross multiply, that's allowed. I would take the x times the x minus 1. Whoops. And then I would take the x plus 1 times the x plus 2. And I'll just write it out quickly, not the whole thing. Like what would you do to cross multiply? And then after you get this, you'd have to distribute everything and expand it out and then try to solve. It's going to end up looking just like what I have over here. So this will end up looking like that, right? When you kind of do all that. So it's nothing new really. It's just kind of a different way of looking at it. And then when you get done, you should be able to like just look at the tops to say is equal to 0, and then you can solve, right? Same thing in all these. Find a common denominator over here first. So I need common denominator. Then I can put all the tops together. And then once I put all the tops together, then I can just say the top equals 0. The top equals 0. Okay, and then same thing. Common denominator, put all the tops together, right? You can see here I'm putting all the tops together. Don't forget to distribute the negative, right? And then I can solve. All right, so very common. This one already has a common denominator, so all you have to do is just say the tops are equal. That makes it nice and easy. This one I need common denominator again, so you can see I did that here, common denominator, and then we just take the tops and solve. Okay, I know I went quickly through that, but it's really the same process every time. Common denominator, common denominator. If you're comfortable, you can cross multiply or you can do it kind of different ways, but it's almost the same as what I'm doing. Okay, and then last little pieces here. They just want you to graph points out. This is just plug and chug. Just put in some values of x, right? Vertical asymptote is at 0 because of the bottom is 0. Nothing cancels, so we don't have any holes or anything. Horizontal asymptote is at 0 as well because the bottom is a higher degree than the top. And you can just plug in numbers. So if I put in 1, I get 1 over 1, right? Oh, sorry. Put in 1, you get 1. Put in 2, you're going to get 1/2. If I put in 4, I'm going to get a quarter, right? Etc. Oh, sorry. Okay, and then when you solve, these are just extra solving things, right? We've already done some solving already. This is just more practice on all these. Again, it's always common denominator, common denominator, common denominator. This one shows you, these show you a little cross multiplying, right? Cross multiply. And then this one, you can see it was common denominator. The one thing I will point out is on this one, when you did get a solution, you can see that we ended up with a solution that did not work in the original equation. If I put -3 into the original, I'll be dividing by 0, and that's undefined. So that is not one of our solutions. We have to eliminate it and then just take what's left over, so the x plus 4. So be wary of that. Here's another one of those where we get one solution that does not work because I'll be dividing by 0. So we don't use it, and we just focus on the other solution that is there, because this was a quadratic, so you get 2 solutions. All right. And then we're going to have you guys do some stuff from unit 2. So this is like factoring from unit 2, a little practice there. And then this is also some writing the equation of a quadratic, right, from unit 2 as well. So that needs to be done. The only thing I'll mention on these is this. In this case, I gave you x-intercepts. So you want to use that intercept factored form. And then I want to find a different point to plug in to find my a value, right? So this goes back to like the ByteMart project and all that, where you have to calculate the a value to go along with your equation. Same thing on this one, right? Here's, they gave me the vertex on this one, so I'm going to use vertex form, and then I'm just going to grab a different point to plug into this to find out what a is. All right, and then you end up with your vertex form. All right, that's enough for this video. Some of it I went through quickly because it's kind of repeats or it's from unit 2. But you can always come in and ask me questions, and you can always go to Miss Patali as well. So come ask us questions if you have them. And good luck on your tests.